Okay, let's do another example in which we're trying to find particular solution for a differential equation. Here is y prime equals to x minus xy with initial condition. So when we have a differential equation, only one differential equation, you can find the general solution. But when you add the initial condition, you can use that initial condition and find the particular solution. Well, let me write what we need to do first. First is find the general solution. The general solution. When you find the general solution, the second part would be use the initial condition to find a particular solution. Okay, so let's start doing the general solution. Here, we have to first figure out what kind of differential equation is this. Um, This, if you look carefully, you can write it as dy dx equals to factor x1 minus y. This is a differential equation, and right hand side you can write it as fx times gy. So it is a separable differential equation. I already did in another video the same example while I considered it as a separable differential equation. But there's another way of seeing this equation, and it is writing it as this. And if you do that, you see that we have y prime plus px times y equals to qx. So this is, in other words, a linear, first order linear differential equation. In this video, I will take it as this and then go ahead and solve it using that formula. Okay, so we'll take this one as first order. So the steps to solve first order linear differential equation is that first write it in the standard form, which I already did. It is y prime plus xy equals to x, and identify px and qx. Here now I know that px is x and qx is another x. Okay, step 2, find the or an integrating factor. Find an integrating factor. Well, find an integrating factor here means what? So we have to first integrate px and then put it as exponent of e here. This means that I have e to the power integral of x dx, and we know that integral of x is e to the power x squared over 2. That's it. Okay, so we have the integrating factor here. Let me put it in the box. Then in the third step, step 3, then we find the solution. Find the general solution. Here what you need to remember is the formula. The general solution is given 1 over ux times integral of qx times integrating factor, and then I'll put that c outside so that you Don't forget it. Okay, here ux is e to the power x squared over 2. Then integral qx is x, e to the power x squared over 2 is also there. Then dx plus c. This c is the same c that we put at the end of the antiderivative. So while I will find this integral, I won't put another extra c. This is the exact same thing. So now we need to integrate really this function e to the power x squared over 2 times x dx. Well, you have to remember here that I have e to the power of function. The derivative of that is x, and it is down there. So basically, I have e to the power gx, then the derivative of gx is there. In this case, if you remember, we do the substitution. So we put u to be, it's not equal, u to be the whatever the function is here is x squared over 2. Then du is the derivative of that, dx, which is x dx. It means that if I want to apply the substitution, this guy is du and this is u up there. So we have the integral of e to the power u du. And e to the power u, we know that antiderivative of that is e to the power u. I will put that c, and then when you go up, I don't include that. Then I need to plug in back that u there, so it will be e to the power x squared over 2 plus c. Okay, and what does this give us is that, okay, we solved it, so we get 1 over e to the power minus x squared over 2 times e to the power x squared over 2 plus c. Why did I put minus there? It's plus. And then you multiply this inside. Plus c e to the power x squared over 2. This cancels with that, and I get 1 plus c. I can take this up there and write it e to the power minus x squared over 2. So the general solution, we found it, and it is equal to, let me write it up here, y equals to 1 plus c e to the power minus x squared over 2. So that's the first part. It's done. We use the formula we have for linear differential equation. Now it's time to apply the condition. Means that, okay, plug in x equal to 1 and y equal to 0 and find c from there. So here it will be 0 equals to 1 plus c e to the power minus 0 squared over 2. Oh no, not 0 squared, e to the power x is 1, so 1 squared. And this means that we have c e to the power negative half. C equals to negative 1, and then this gives us c equal to negative 1 over e to the power negative 1 over 2. But this can come up. We can write it minus e to the power half, which is the same thing as root e. I'll keep it this way to show you what will happen. So now that I found c, I have the general solution. I plug in c into the general solution to find the particular solution. Here, then y is equal to 1 plus c is negative e to the power half times e to the power minus x squared over 2. And well, if I want to simplify it a little bit, you see that e to the power half times e to the power negative x squared over 2. I can write it 1. This minus sign comes out. E to the power minus x squared over 2 minus half. And that is the particular solution we were looking for.